Hey guys, and welcome to another Tuesday trick, where today we'll be looking at cos double angle identities and picking the right one, right? So there's three different cos double angle identities, which makes it quite tricky when knowing which to pick. So when it comes to trig proofs, there is a simple trick. So let's kick off. So there are three cos double angle identities, and what are they? Whoa, how did I get there? I'm just a math magician these days. Okay, so the key is when we have trig proofs, how do we know which one to pick? Well, in order to understand which one to pick, we need to understand what are the purpose of identities. And the purpose is to simplify the problem. Right, so when we have a proof, we want to use identities to simplify the problem. Now in maths, what's one way to simplify the problem? Well, it's reduce the number of terms. So we can reduce the number of terms in a problem. That makes life a whole lot easier for us. So that's the trick we're going to use here. We want to use the cos double angle identity that reduces the number of terms. So how can you recognize that trick? Okay, look at this. 1 plus cos 2 theta equals 2 cos squared. 1 minus cos 2 theta equals 2 sine squared. That's just by rearranging this. So if you have a double angle in the question for cos, and then you've got a plus 1 next to it, that means we use this identity because the 1 will cancel with the minus 1. And same with here, we've got a minus. So that minus will cancel with that 1. So the aim is for the trick with the cos double angle identity is pick the cos double angle identity that will eliminate the 1, which is either going to be one of these two. This identity is rarely ever used in trig proofs. It has other uses in other places, but in trig proofs, it's usually going to be one of these two because we want to eliminate the 1 in there. So, whiteboard's clean. And let's look at an example now of how to apply this trick. Let's consider this example. Prove 1 plus cos 2 theta plus sine 2 theta over 1 minus cos 2 theta plus sine 2 theta equals cot theta. So clearly here, we can see we've got double angles everywhere and we've got this 1 plus 1 minus. So what we're going to do is we'll start with the left hand side, and straight away we know the trick is we want to sub for 1 plus we sub in the 2 cos squared identity because that cancels the 1, so that just turns into 2 cos squared theta. Now what's sine 2 theta? Well, luckily sine 2 theta double angle identity, there's only one option to pick from, which is plus 2 sine theta cos theta over. Now we've got 1 minus cos 2 theta. So which one cancels the 1? Well, that's the sine squared identity, and you should know 1 minus cos 2 theta is just 2 sine squared theta, and again, sine 2 theta only has one option. So from this point, to help us, I did a tutorial a couple of weeks ago on the manipulation list for trig proofs, which I'll leave a link up to here. So the manipulation list is E, F, A/SS. So at this point, what's my next step? Do I need another identity? Well, let's go through the list. Do I have anything to expand? No expansions. Factorize, yes. Right, lots of common factors here. So we can factorize by taking 2 cos theta out, and we're left here. And then on the bottom, we can take 2 sine theta out, and we're left with sine theta plus cos theta. And then look at this, they cancel. The 2's cancel. I'm left with cos theta over sine theta. We're trying to prove that equals cot theta. Go down the list, that means we need another identity, but that is just cot theta by definition, which equals the right hand side. So you can see, by knowing this trick with the cos double angle identity, it makes solving these proofs really easy. So the key is to know which one it is, and it's the one that eliminates the 1. Sine double angle is just 2 sine theta cos theta, so there's no problem with sine 2 theta, it's just the cos double angle identities. So I hope you enjoyed this tutorial, and I'll see you tomorrow for Wednesday. Whoa, you made it to the end. Thank you for watching, and I hope you learned something awesome today. I post 6 videos a week, Monday to Saturday, so make sure to subscribe here, turn those bell notifications on, and watch other awesome videos on my channel right here, okay, right here. Oh yeah, don't forget to like, comment, and share. Spread the maths love. Can we go to the gym now?